Hey, so in today's video, I'm going to revisit the B problem. I've done a couple of videos on the B problem. It's from ImageSC, quick look at it. You can find it on the forum, uh, counting Bs. And a bunch of great solutions presented. One of the things I did was try Stardist on it, and I already did a couple of videos on this. New video is going to go over a couple of new things. One, Stardist now supports Sparse label masks, and that's a really powerful feature. So I'm going to go over what that is and why it's so great. And then I'm also going to take a quick look at MobileSam, which is a YOLO+SAM variation. And then as a quick side note, I'm going to show you guys some of my dependencies. I've been having some kind of speed issue, which is probably something on my part, but I'll just see if anybody, throw it out there to see if anybody has any insights. Yeah, so in this thread, first, a while back in December, it was mentioned among a number of solutions, which included Cellpost, Stardist, YOLO was mentioned, good solution. And today, coincidentally, it's mentioned that for segmentation, maybe SAM is even better than YOLO. So let's talk about that for a second. So I think in my last video I showed this the plant roots. I showed this. I used this labeler to try to improve the labeling process. And if you looked at it closely, you may have noticed that there was this label only parameter which I had set to true. So if you're brave, you can set label only to false, and then the label widget comes up with a bunch of more options, and it becomes a augmentation plus training plus prediction plus labeling widget. Very experimental. A lot of the functionality is not implemented yet. So again, if you try this super mode, take a lot of care. All this functionality also relies on the proper Python packages being installed in the back. So I don't want to make any claims about this plugin that aren't true. It's just a very experimental widget for trying different deep learning methods, but not something that is polished or tested at all yet. Okay, so that being said, one of the goal here eventually, someday, is to be able to quickly evaluate the different deep learning methodologies or different deep learning approaches in the same plugin. And so you have this menu here, and you can choose the popular options: Stardist, UNet, Cellpost, MobileSam. So what is MobileSam? MobileSam is kind of a YOLO-SAM combination. I think I have a link to the GitHub repository, which also links the paper. And what it does is it uses YOLO to predict bounding boxes, then SAM to predict the segmentation masks, and it's a very, very general model. I don't have all the details on the top of my head right now, but let's take a look at this MobileSam, which is a YOLO+SAM combination. So, yeah, first caveat: this stuff is really new, and to segment complicated images, it still takes a long time to run, even on good GPUs. But what we're going to see here is this is the result of the YOLO part of MobileSam on the B images. So we have a bounding box around each object it detected, both Bs and some of the cells in the honeycomb, I assume. And just a second here, we also have the predictions. So SAM is a prompt-based system, so it takes in a prompt, which in this case is the bounding box generated by YOLO, and makes, from that, computes masks. So we're looking at bounding boxes from YOLO masks from SAM. And let me turn the bounding boxes off, and then we can more easily see the just the segmentation. So what do we have here? We have SAM predictions, and so I've been testing SAM a few months, and from what I've heard from other people, it's spectacular for annotations, because you actually, SAM needs a prompt. When you're annotating, you form a prompt by pointing at something or drawing a box around it, but SAM is much trickier when trying to process an entire image. And sometimes the problem is simply that it just returns too much information. Sometimes, because in this case it's segmenting Bs, segmenting cells. If you zoom in on this, a lot of times it's segmenting parts of Bs, and it's actually probably doing it properly in many cases. Like sometimes it segments a wing, sometimes it segments the body of the bee. Other times, like right here, it's sort of segmented the eyes. So it's a spectacular segmentation method, but it's not very precise. It's segment anything, segment everything, and that's literally what it's doing. But what do we do with all this information that it returns? I mean, that's yeah, I think that's an ongoing question. Some people have been discussing it on the forum. If you have any insights to how to process entire complicated images with SAM or YOLO, love to hear them. But yeah, that was SAM and YOLO on the bees. Now I think I'm going to move on to the sparse annotation. Okay, so sparse annotation. Here are all the dependencies you need to install to get the sparse annotation working. This is not the, it doesn't have the SAM in this. So again, if you want to try to install SAM, maybe start a discussion in another topic or something. One thing I've been running into lately is TensorFlow version after 0.9 is intermittently slow for me. Be curious if anybody else has found that. Here's my installation instructions for TensorFlow on Windows. If you see anything wrong, I'd love to hear about it. Okay, so sparse labeling. Finally, I've got into this sparse labeling. Okay, so I mentioned I've been playing around with this label helper, which has which in label only mode, it's kind of getting pretty trustworthy. If you turn this label only to false and you get all the functionality, no guarantees. But let's bring the bees back up. Okay, bring the bees back up, sparse labeling. What I want to do is I want to point my labeler to a directory just containing some images I want to label. So I have this directory here. It's called super sparse. I'm going to experiment with super sparse labels a bit. So I let's point to there, and we should see Napari come up. Okay, when I bring this widget up, it asks the number of classes. There's only one class for the bees, so just press 1, and we get the bees. We have 2 bee images, so we can scroll back and forth between them. If we had 1,000 images, you could probably look at them all as a series. So that's what this widget kind of is useful for, labeling things as a series. We want to label some bees. One thing we have to do is we have to put a label box around the area we want to label, because in many cases we might not label the whole image. We could probably do something clever like label parts of the image and then automatically detect. But I think it's better to be explicit, because you may really want to just say, I don't want to label this part of the image. I just did this part, and make sure you make that decision instead of having some like automated detect which area was labeled algorithm make that decision. Okay, so we got a label box. Now let's label. Sparse labels. There's a couple of differences when we're doing these sparse labels. This is really new. I don't know what the best protocol out there is, if there's been some recommendations yet, but playing with it, this is what I have found. First off, we used to not have to worry about the background and just label the objects, right? But now that we have sparse labeling, it kind of what it means is not everything's going to be labeled. So I think when I've been playing around with it, I found it works better if you actually label some background. So here I'm labeling background. I'm labeling it as 1, and I'm going to have to remember that because I'm going to have to manually make a little bit of adjustments. So what the sparse labeling does is everything labeled as negative is just not included in the training calculations. 0 is still background, and integer indexes are objects. So what I'm doing here is I'm going to label background as 1, then label the objects with higher indexes, but then when I eventually try to make patches out of this, I'm going to subtract 1 from it. So then this background here, which is 1, becomes 0. The unlabeled stuff will become -1, and the label image will be ready for the sparse training algorithm. So we're on the labels. Let's do some bees. The bees are so easy to label. It's just you got to get the brush the right size, then make a bee label. Then we can increment it, make another one, and this is now that it's sparse, this is actually kind of way easier because I don't have to concentrate on getting everything. I can just quickly get the bees that are sort of obvious to me. So I mean, it's not this. What I have found is the speed increase isn't just like if you only label half the objects, the speed increase of labeling is like more than half because you don't have to, something about it, you just don't have to concentrate as much. And you can quickly, get a bunch of bees. And I will pause the video for a second. So I've sparsely labeled bees, and now I'm thinking, you know what, I want to go back, make some more background. So I'm changing this back to 1, making some background, make the brush bigger for the background. There we go. A little more background here, a little more background maybe here, maybe get a couple of the corners. Okay. Okay, a few more bees in the corner here. I did a lot of them off video. Yeah, then we got some sparse bee annotations. And if you ever try to use this widget, one thing you have to remember to do is save your results. And then you should end up getting your labels written to disk. There they are, the two little sparse labels I did. Okay, so the next 2 steps are creating the patches and training, and I've shown similar notebooks before. For the sparse version, there's one key trick here. You have to actually subtract 1 from the labels, because remember, 1 was background that we labeled, and we want it to be 0, and we want everything not labeled, which is 0, to be negative. So after running the augmenter, I've mentioned this before, I always save my augmentations to disk. Don't know if that's not the way most people do it. I like to look at them. You can see here I probably made too many in this case, but you can see I've got a bunch of tiny bee images now. And then after augmentation, we go on to the training step, which is similar to before. Now, one thing that I've been running into, I've been having some speed problems on Windows. Maybe that's something I should bring up in a thread again. But what I'm going to do is actually go stop the video, train this on Linux, and come back. Okay, so I just went ahead and trained a model on a couple of the sparse label sets. And I don't expect anybody, this is throwing a lot out there in this video, so I'll probably do some, hopefully in the next few weeks, do some better training videos on some of this stuff if I have time. But so don't expect anybody to be able to totally make sense of this, but here's our sparse label, and here's the model that was trained. Not too bad, right? I think my video is going to cut me out, But that's our sparse Stardist prediction.